Hello everyone, welcome to TypeScript Today, and today we're going to talk about some non-obvious behavior that we sometimes see in some TypeScript types, namely the distribution behavior. Now, some of you might already be familiar with this from conditional types, where if the conditional type is expressed over a naked type parameter, for example, such as in this case, then this type will distribute. What exactly does this mean? Well, this means that if we apply our conditional type to a union, basically what's going to happen is that extract string will be applied to each constituent of this union. So it's going to first of all be applied to 0, then be applied to 1, to yes, and so on. And the result is going to be a union of all these applications. So what we have here is extract string of 0, of 1, of yes, and of no. Now if we were to replace 0 in this expression, well, 0 doesn't extend string, so what we will get is never. Same applies for 1. What about yes? Well, yes extends string, it's a subtype of string, so that gets preserved. And of course the same for no. And the end result will be that never gets reduced in union, so what we're left with is yes or no. And if we hover over the type, we see this exact same result. Now, the reason this is sometimes surprising is that if we actually inline the type, so if we actually were to, for example, write our own type R2, where we have the union and we ask, does it extend string? Well, this union in itself doesn't actually extend string because it contains numbers. Those aren't subtypes of string. So we cannot say that this union is a subtype of string. So what happens here is that R2 will actually result in never. We can even create conditional types that aren't distributed. For example, if we express the condition in a way that isn't a naked type parameter. For example, if we want to disable distribution, a common pattern is to put the type parameter in a tuple and then put the condition we're trying to test also in a tuple. So in theory, we would get equivalence here. So if we were to apply this to, for example, the union that contains numbers, we will see that this actually results in never, because again, the union itself doesn't extend string. If we were to have just yes or no, the union itself does extend string, so we do get yes and no, but distribution still doesn't occur. So these are, in a nutshell, distributive conditional types. Now, what is less obvious is mapped types also have a distributive behavior. Namely, mapped types that map over key of t, where t is a type parameter, are also distributive. So let's take a look at this node's union, and we're going to create a mapped type that maps over key of t. Right, so we're transforming all of the properties to property type boolean. Let's say we want to keep some validation for each member. Now, if we were to apply this type to our node's union, we can see that the result is also a union. We can see that basically what happened is that this validation type was applied individually to each constituent of this union, and the result was also a union. Now, if we were to inline this type, namely if we were to create a type R2 that maps over key of nodes, well, key of nodes just gives us type because that is the only common property between these two constituents of the union. And what we actually get is just a single object type that contains the type property of type boolean. So what happened here is that we didn't get distribution because the mapping didn't happen over key of a type parameter. It happened over key of a concrete type, the node's type. Not all mapped types are, of course, distributive. For example, even the validation type we wrote before, if we were to do some sort of manipulation of the keys, for example, try to extract just the string keys, then this type itself would not be distributive either. So if we were to apply this type to our nodes, we'll see that again we get type of boolean without actually having the distribution happen over the constituents of nodes. Now, some predefined mapped types are distributive, but not all of them. So for example, let's take our nodes union again, and let's see what happens when we apply some predefined types. So for example, if we apply read-only, we actually get a union of the two constituents. We get read-only of the first constituent and read-only of the second constituent. So read-only is distributive. So is partial. So again, if we apply partial, we see here that we get a union as a result. And so is required. Required is also a distributive map type, because if we go look at the definition of these types, we can see that their mapping happens over specifically key of t, where t is a type parameter. Some map types that aren't distributive are, for example, pick. If we look at pick nodes, we see that we get a single object type. That type has indeed type A or B, but that comes because if we were to index into nodes with type, we would actually get the union. But we notice that we don't get as a result a union or a union that contains two object types. We get just a single object type. So again, distribution didn't happen in this case. And another type that isn't distributive is omit, which is a combination of conditional and mapped types, but again, it is not distributive. We see here that, for example, size is missing from this result, and also we see that we didn't get two unions, a union with two constituents. We just got a single object type. So again, distribution didn't happen. I hope this was interesting for everyone. Don't forget to like and subscribe, and see you soon.